Hello. Now we will see how the charge will get distributed across a metallic plate. So first we are starting with single plate. So I'm having this single plate, it is having some thickness, it's metallic plate. And we want to see if I provide, let's say, capital Q charge, positive charge, let's do it positive charge. If I provide this plate positive capital Q charge, how that charge is going to get distributed onto two of its surfaces. I'll be assuming zero charge here and here. Okay, because the thickness will be very small compared to the area, cross-section area. So I'm giving it plus Q charge and we want to see how it will be getting distributed. Okay, so let's assume out of the positive Q charge, capital Q charge, some of the charge had went for this side. This is side 1 and this is side 2, I'm calling. So this charge is plus of small q. So out of this total charge, this much charge has went for the second surface. So obviously there is a relationship, and if you remember, net charge is constant for the universe and charge is indestructible. So charge cannot be destroyed. So out of this total, if we are sending this much charge, small q charge onto the second surface, obviously remaining charge will come onto the first surface. So capital Q minus small q. So if you add these two charges, you get this much. Okay. Now we want to check what's the value of small q, because the moment we get the value of small q, we'll be getting the value of this also. So we'll be having the idea how the charge, capital Q charge, is going to get distributed on either side of this metallic plate. Okay, there is only this single metallic plate is there, and there is no external thing is there, meaning there is no external electric field, nothing is there. Okay, so this is your metallic plate, and regarding metallic plate, we already know that inside the metallic plate, field is always zero. So let's assume a point P. I'm assuming a point P inside the metallic plate. Okay, so this point P will experience two electric field. One electric field will come from the surface 1, and obviously this is a positive charge. So because of the positive charge, electric field is away from the positive charge. So this will be, I'm calling it E1. So this is because of the positive charge onto the one surface, electric field on point P will be onto the right hand side. Similarly, this small q charge will apply the electric field onto point P, and I'm calling that E2. So net field at point P, that is a vector summation of E1 and E2. That will be 0. Reason being, this P point is inside the metal. This P point is inside the conductor. Since P is inside the conductor, we can say EP is 0. That makes that E1 is equals to minus of E2. Now let's calculate value of E1 and E2 magnitude wise, because the minus sign signifies the direction and we have already taken the direction in opposite direction. Okay, so if you see this side, since this thickness is very small compared to the cross section area, we can assume this side to be infinite dimension. And this is a plate, obviously this is one side of the plate. So because of the single side of the plate, the electric field formula, if you remember, because of the single side of the plate, formula for electric field is sigma upon 2 epsilon naught. If you remember, that's the formula. Okay. If both sides we are taking single side, so it is sigma upon epsilon naught. So E1 will be sigma upon epsilon naught. And the value of sigma, this cross section area on both the sides, I'm taking capital A. So sigma is total charge divided by total cross section area. So total charge on the one side, I'm talking about one only right now, capital Q minus small q divided by capital A. So that becomes the density. Total charge divided by cross section area becomes the density on the side 1, and if you divide by epsilon naught, you get the electric field. This is 1. And if you talk about 2, the magnitude wise, that will also be equals to sigma upon epsilon naught, only the direction will change, and sigma we can calculate by dividing the total charge on the second surface with its cross section area, which is similar to the 1 epsilon naught. So now we got both the electric fields acting at the point P. You see, at point P, net field is 0 because it's a conductor, but the fields are there. Individual fields are non-zero. So let's put that. Let's use this equation. This is Let's call 0 equation 2. So if you put the values, we'll get capital Q minus small q is equals to Q upon A epsilon naught. That makes capital Q is equals to 2 times of small q, and that makes small q is equals to Q by 2. So you see, if I'm having a plate, metallic plate, and if I'm going to give it capital Q charge to the plate, so what we are seeing here is the half of the charge will go on one side and remaining half is going on to the other side. It's not like this will only happen with the positive charge. Even if you are having a negative charge, the same thing will happen. So whatever charge, if there is a single plate and that single plate is placed in a vacuum when there is no external influences there, and if you provide some charge to that plate, the charge will get divided into equal amount on either side of the plate. So that property you can memorize, that relationship you can memorize, you can directly utilize it while solving the questions. Okay, thank you.